Alright, so let's talk about sensors today. So what kind of sensors that we use, or how we treat different kinds of sensors. And also we'd like to understand the physical meanings and the physical relations between the sensors and the data gathering systems. So first let's talk about different types of sensors. Okay, popularly we use strain gauges. So we measure the strains. The strain gauges are most basic types of sensors, and then we learn the use of sensors in mechanics of material classes and also structural engineering. We measure the strains. And then the another category is displacement sensors. So we measure the displacement. Basically, we do not measure displacement, but elongation. So we measure the length change. And then also we use the temperature sensor. So there are various sensors. Okay. So let's talk about the physical principle behind the sensor theory. So whenever we develop a sensor, so let's imagine a strain gauge sensor. So if you have a strain gauge, if you look up closely a strain gauge, so we can recognize, there is very thin wires. The thin wires are curved in this way. So here, although its length is very small, but because the wires are curved, the total length of the wire is very big actually. Then what we do is we apply a voltage, and then we want to measure the resistance. And what we do is, so we apply the elongation here. And let's say to original length we have some elongation. Then by the definition of the strain is elongation divided by the length of strain. This is the strain, right? Okay, let's say if you measure the change of resistance by the strain development, then here the horizontal axis is strain, and then by the change of strain, the resistance is also changing. If we measure the change of resistance at different strains compared to the initial resistance, then its behavior is almost linear. Okay, almost linear. And then by regression, if you develop a sensor, if this regression line is almost linear, then you may want to say that you develop a good sensor. And the slope is called the gain factor or gauge factor. Gain factor or gauge factor. And then the strain. So once you measure the resistance, the change of resistance, we can measure the strain. The strain can be estimated by this relation. Strain is equal to the gauge factor times the rate of the change of resistance. Okay, so basically look at this. So we measure the resistance of wire, okay, to measure the strain. What does it mean? If you step over a strain gauge, or if you apply a loading on top of a strain gauge, then it would cause the change of resistance. That's why you would get fictitious change of strain, isn't it? So you should avoid it. So if you attach a strain gauge, okay, let's imagine that you have a surface. You have a surface here. If you attach a gauge here, then typically we have to provide a housing on top of strain gauge. This is a protect housing. Protect housing. So otherwise, any pressure on top of strain gauge would cause the change of the gauge factor or the change of resistance of the strain. That's why my strain measurement would be contaminated by such things. Also, some of students, during experiments, they use, the cellular phone. So what happened? The electromagnetic wave coming from your cellular phone would produce additional resistance. Okay, that also contaminate your strain measurement too. Okay, now let's talk about data gathering system. Okay, so in these days we use computers. So we usually bring computers. It can be laptop or it can be desktop if you do the experiment in a laboratory. And then here this computer is connected to so-called data logger. This is called data logger. So please refer to my recording on how to use TDS series. And then this data logger typically provide a number of channels to strain measure, okay? And then let's say each channel is should be connected to different sensors. For example, sensor 1, and this guy would be connected to sensor 2. Let's say the sensor 1 is for strain, and this is for displacement. Now what does it mean? Different sensors, okay? Different sensor means the gauge factor cannot be same. That's why when you set up, when you initialize data logger, so you have to pay attention to the gauge factor. This is very important. This is crucial thing. So if you use data logger without caution, then you would have some strange value of gauge factor, which produce, very strange strain distribution. So you have to check your strain development first. So I recommend you to do the test before any strain measurement. You apply a strain on top of a certain small structure where we can calculate the strain analytically, and then you try to measure the strain using your data logger and your computer system. And you have to check your strain is the same as what you expect in advance. This is very important, okay? Let me stop my recording here regarding the sensors and the use of data logger.